Hello! This video is about creating a georeferenced 3D scans like the here currently shown on the right, using pretty much DIY level equipment. All applications used are free and open source software. This is based on a rig containing 3 GNSS antennas and receivers. You can see more detailed explanation of in the other videos in this channel. But in short, it's possible to solve the location and orientation of the rig using the locations of those 3 GNSS antennas. In addition to a camera, this also has this rotating lidar attached to the rig. Laptop is used to log the data. Let's see how this works. This hair statue is about 35 centimeters or 1 foot high. The lidar is now scanning its surroundings, but because it's working in infrared range, we can see it working. But since the measurement data is available, we can draw the measured points and visualize the laser lines on top of this video. Here green dots represent points that are considered valid and used as points in the point cloud. Lines are also color-coded: green for valid measurements, other colors represent different invalid conditions. All of the green dots were used to generate mesh for the hair model. Base antenna can be seen on the background here, on top of the black pipe. Remote entry base could also be used. I didn't use one because the one I used was covered by snow and is practically inaccessible in this weather. Using remote base would also make wireless rig possible. Slight wobbling of the points in relation to the background is partly caused by the image stabilizer of the camera that can't be turned off completely. If it was completely off, the laptop screen on the left and the lidar and its mount would be almost stationary on the video. Here it can be seen that the lidar doesn't see the black pipe underneath the statue almost at all. This view isn't really interesting, so let's switch to virtual mode instead. In this mode it's possible to fly around quite freely. So if we back up a little, we can see the rig in motion. And we can also slow down the time. Then we can take a closer look how the lidar is working here. So it's basically scanning in a circular pattern. It rotates about 20 times per second, so here it is about once a second. Since this is 1/20th of the speed. Now it's scanning only the ground, so the lines are red and yellow. Red lines indicate that the measurements are outside of range. that can be defined here. So soon it will start taking valid samples again. Oops. The black eyes actually seem to be quite problematic for this lidar. They don't seem to reflect that infrared radiation too well. It can be seen on the final point cloud also. There's practically a hole where the eyes are. So let's get back to this camera view. The ears are also problematic. There's the same black color there that the lidar can't see. So now it's now the points are collected and we can take around this. Texturing of this hair was done in Meshlab by hand. Basically it could be automated somewhat because the location and orientation of the camera is known for every moment. Collecting the data and generating a point cloud out of it is maybe a bit out of scope of this video, but let's take a quick look on the point cloud itself in Meshlab. Here's the point cloud gathered in the previous process. As you can see, it's about 65,000 points or vertices. These points here are practically outliers. They were sampled from the pipe supporting the statue, and since they are so sparse, it's better to get rid of those. They spoil the surface reconstruction process. And those eye areas, it's interesting that they are practically holes, and the holes are much bigger than the black eyes on the statue. I don't know exactly why this is the case, but it is what it is now. So let's try to construct some surface out of this. If we try to construct too detailed surface, it looks quite weird, or at least this is not very healthy hair, so it's better to use a bit less detailed parameters like this. And since it's still, at least here, have too much details, we can smoothen it a bit, like using this operation. This is very close to the mesh you saw in the previous parts of this video. I used the same parameters to generate it, but there might be slight differences in the lower part because the points removed may not be the same ones. So that's pretty much all for now. Thanks for watching and read the description for more information.